Welcome to the final and third session of a three-part Mathcation Fluency series developed by the Teaching and Learning Collaborative. TLC is a nonprofit organization that creates innovative resources and professional development initiatives for teachers in math, science, and computer science. We are excited to dive into numerical fluency with you. We cannot wait to hear your Seaside stories. We would love for you to share your experiences as you dive into fluency and splash towards understanding. We would love to see pictures of your Mathcation experience. You can share these with us via email or Twitter. Please be sure to tag us at Connect to TLC and use hashtag TLC Mathcation. You can also follow us on Facebook and include us in posts. We can't see your personal posts, but if you share a post on our page or tag us, we can share it too. Plus, we have a few special surprises in store for pictures, tweets, and posts. If you don't want to share on social media, but still want to share ideas, please contact us via email. Contact information can be found in the SMORE newsletter you received.
We have concepts that are all mixed up. We need your help in reorganizing them and thinking about the connections that you can make. So in just a moment, you're going to pack up and surf over to your digital journal. When you get to your digital journal, spend about 5 minutes reorganizing the concepts, making sure that you're drawing arrows to create a web and making those connections between concepts. Don't forget to label your connections. Welcome back. We hope you had a great time making lots of connections, and we'll continue to think about those connections throughout our learning today as we unpack and formalize that understanding of fluency. Here is one example of how your concepts could be connected. This chart comes from the Ohio Department of Education. Here you can see how story problems really are at the highlight and the forefront of which fluency is developed. Additionally, you can see how number talks and/or games can be implemented through those blue boxes of building mathematical understanding, using strategies, and developing efficient and effective skills and procedures in order to get to fluency. So when we think back of all of the stops we've made along our Mathcation journey so far, we can really see and can determine how all of these pieces can start to fit together to create fluent mathematicians. It might be 5 o'clock somewhere, although on our Mathcation right now, it's 3 o'clock, or maybe 3:14. Thinking about this image, there are a lot of connections to number talks and the role of mental math in fluency development. Depending on what you notice, there are a lot of ways you could make sense of the clock, and various strategies can be shared when justifying your thinking. Number talks is a powerful instructional strategy, not only for developing fluency, but also for using justification and reasoning to develop understanding of numbers and operations. The structure of a number talk can remain the same, while what is presented to students can look differently. Let's take a look at some of the different types of number talks. All of these ideas, when presented with purpose, allow students to reason, justify, and think flexibly, which are at the heart of a number talk. A number talk provides a collaborative environment for students to invent strategies, generalize strategies into personal algorithms, and build a conceptual bridge to fluency. Let's take a look at a number talk in a classroom to see how some of these ideas can come alive. In a moment, pause the session for a movie by the pool. The movie is about a different type of number talk than what we have experienced so far on our Mathcation. When you are all settled in and ready, your movie can be found on page 36 of your resource book. While watching, consider the pivotal understandings. Afterwards, in your journal, reflect on what pivotal understandings you noticed and connections you can make about fluency development. Welcome back. We hope you enjoyed your movie poolside. While watching the movie, you probably saw many of the following instructional supports used during the number talk. When number talks are implemented, the teacher is the facilitator of learning. It is through our questions that uncover student thinking and the ability to understand how students apply number relationships flexibly. The structure supports teachers in shifting their teaching to using student thinking as a pathway for fluency development. Teachers make use of student strategies and number sense to reinforce numerical fluency. During a number talk, students are sharing their ideas and all answers are accepted and justified. Number talks focus on strategies, thinking, and alternative approaches to solving. Through discussion and listening, this structure enables students to build fluency in meaningful ways and apply their fluency knowledge. So you might be wondering, how do number talks support fluency development? Take a moment to read this quote about number talks. When you think about daily fact practice for students, using number talks is one of the best instructional strategies you can implement regularly to develop fluent mathematicians. This 10 to 15-minute instructional time, when used as intended, can have a significant impact on student learning and mathematical growth over time. Research has shown when conducting a number talk, it is imperative for students to be able to see a connection between the numerical and the visual representation. It is through this connection when the deepest learning occurs. If number talks are a new idea to your learning, you can find more information about how to implement these in your digital journal.
Welcome back. In session 2, we took a deep dive into games and what makes a game rigorous. In this session, we are going to take a look at why researchers advocate for games in fluency instruction. So one reason is that games support automaticity. And so games promote numerical fluency by practicing strategies to the point that they are automated, which promotes fluency. Automaticity and memorization are not synonymous. Students pull strategies from memory, which looks like memorization, but it's really automaticity. When games contain components of rigor, the standards for mathematical practice are at the forefront of learning. During gameplay, students are engaged in SMP 1, making sense of problems and persevering to solve them. Students also experience SMP 3, 5, and 6 through discourse. Students are expected to use accurate mathematical vocabulary and justify their thinking and reasoning. Throughout the justification process, students may create models to prove and explain their thinking, which leads to SMP 5 and 6. Another reason we advocate for games is that rigorous strategy-based games promote conceptual understanding, leading to numerical fluency. This also supports SMP 7 and 8 because they're looking for and recognizing patterns in order to create a rule or generalization. Playing the game over and over again allows students to continue to test and refine their generalizations or rule. One pivotal understanding that can be accessed through the use of games is pivotal understanding 4, properties of operations. While playing games, conversations about the properties happen organically, which encourages students to explore ideas and gain understanding through experiences rather than memorizing these properties as rules or vocabulary words. The understanding of these properties is something that is developed over time through an emphasis on patterns and generalizations. Students should be able to use these properties and understand how and why they are using them. Properties of operations are not rules or vocabulary we merely give to students to memorize. So let's surf toward the understanding of these properties. The commutative and associative properties help build an understanding of equality. They also help students decompose and recompose numbers, which is key in numerical fluency. A deep understanding helps students master the idea that addition and multiplication are commutative, while subtraction and division are not. These properties also reduce memory load by allowing students to think about multiplication while solving division problems. Students need frequent practice to use these properties naturally. The distributive property allows students to use known or derived facts to solve unknown facts. Similarly to the commutative and associative properties, it is also a tool for reducing memory load. Students need many concrete and visual experiences with arrays to develop a conceptual understanding of this property, which can happen naturally through the use of games. So I must reiterate that these properties are not rules or vocabulary we give to students to memorize. As teachers, we do not simply teach or tell students these rules. Through many experiences over time and with a plethora of opportunities to find patterns and apply generalizations, students will begin to identify and create these rules through their own understanding that has been gained. So in just a moment, we will have you pause the video and fly over to your digital journal along with the resource book from your Mathcation box. Take a look at the game called Make the Product in the book Developing Numerical Fluency on page 125. Play a few rounds of the game by yourself or with a partner and answer the questions that are in your journal. Go ahead and pack up now and surf over to your digital journal. Welcome back. We hope you had a wave of fun while playing Make the Product. Let's take a look at the original version of Make the Product from your book. So you may have noticed that some of the components of rigor discussed in session 2 were missing. Some of them, however, were there. The ones that we see listed here were seen in the game. So the game has a heavy focus on building a conceptual understanding. It's based in strategy where students must problem solve and reason to determine their next move, and students can play it over time, finding different products. However, some variations would need to be added to extend and deepen mathematical thinking if playing the game over time. Some suggestions for variation can be seen here. So asking students about patterns that they notice and patterns they notice between specific products and how they can create shorter or longer paths. 2 questions that would help students begin to see commonalities between factors and multiples are listed here. We want to be sure we always ask students to analyze why a pattern appears in order for them to begin to generalize and develop conjectures and rules. If there are any products that don't contain one of the numbers in their paths, we want them to think about why that is. Or if there are numbers on the board that appear in their path for each product. So hopefully the missing components of rigor jumped out at you right away. So some of the ones that we caught that were missing were communication and recording student thinking. So students should be communicating their thinking and reasoning with each other, as well as recording it on a recording sheet or dry erase board or some way that they can actually connect that written understanding to their concrete model. A discussion or follow-up was also missing from this game. So this would give students an opportunity to describe their understanding, discuss strategies, and explain solution pathways. These variations extend and deepen mathematical thinking, and they were not there, and we just discussed some of those variations you could create. However, the ones that we listed are not the variations that this game is limited to. So here at TLC, we took the time to make some adaptations to this game in an effort to make it more rigorous. The adapted version can be seen here. So you'll want to go ahead and pause the video and take a look at the adaptation and consider how numerical fluency is supported by this adaptation. Okay, so now that you've taken some time to analyze the game, we will tell you the thought process behind some of the changes that we made. So, the added recording sheet requires students to show their strategies and justify their thinking, which allows them to engage in SMP 3. Because students must use accurate mathematical vocabulary in their justification, they're also engaged in SMP 6. Throughout the justification process, students may create models to prove and explain, which allows them to strategically select tools engaging in SMP 5. The reflection after the gameplay allows students to look for and recognize patterns in order to create those generalizations that we keep mentioning. So, as you select and create games to use in your mathematics classroom, we hope you'll keep the components of rigor at the forefront of your decision-making process. Be critical of the games you select and trust your own knowledge of fluency enough to make adaptations that will benefit your students. So, there are two pivotal understandings we haven't yet skimmed the surface on. One of those is pivotal understanding 2, that all quantities are composed of parts and wholes. So, some critical aspects of numerical fluency are listed here. These ideas are not obvious to students, and they need many experiences with numbers and operations to solidify this understanding. Students develop this pivotal understanding through composing and decomposing numbers, gaining comfort and confidence with small numbers to aid in problem solving with larger numbers. Subitizing and seeing small wholes also helps to develop this understanding. And knowing and understanding the concept of +1 and -1, which later transfers over to multiplication when students add a group or subtract a group to solve for an unknown fact. And the final pivotal understanding left to mention is one that is foundational for numerical fluency and mathematical understanding. And this is pivotal understanding 8, equivalence in equations and the meaning of the equal sign. Many students actually have a rote understanding of the equal sign and identify it as the symbol to show an answer rather than a symbol that indicates equal quantities. Your resource book gives the example of 3 plus 4 equals blank plus 2. How do you think your students would fill in this blank? Surprisingly, many students may put 7, 9, or some other incorrect quantity based on their misconception of equality. So, how do we clear up this misconception and help students gain an understanding of equivalence? Well, students need many opportunities balancing equation using concrete materials. Using true-false statements during number talks can also help build this understanding. With these statements, students must determine if the quantities on both sides of the equal sign are the same and justify their thinking. Some examples of this can be found in your resource book on page 17. The recording of student strategies by the teacher during number talks is also critical, and often it is overlooked. So go ahead and look at the example shown here. Here you can see two different recordings of the same student thinking to solve 8 times 2. So in this example on the left, the teacher that's recording can be creating a misconception here because based on what we know about equality, this would mean that 10 times 2 is equal to 20 minus 2, which is equal to 18 minus 2, which is equal to 16. However, we know that that is not true. All of those quantities are not equal. The example on the right, however, would be a more precise and accurate way to record student thinking. It is crucial that teachers do not string together equations that are unequal, creating and solidifying misconceptions for students. So when you think about recording for number talks, we want you to think about recording in the way that you see on the right. If your students are stringing together equations, like in the example on the left, you want to address that with them because we want them to be precise in their mathematical thinking and reasoning and how they communicate their ideas. And if they communicate their thinking in this way on the left, that's not precise or accurate. So now that we've hit on all of the pivotal understandings, we want you to look at this chart. So go ahead and take a moment and consider where you think students were able to experience each pivotal understanding in these activities: story problems, number talks, and games. So here's what we thought as we looked at these understandings in connection to these activities. So it's not very surprising that each of the activities we focused on could get to every one of these pivotal understandings. It's important to recognize that based on student strategies, these activities may not get to the pivotal understandings. So teacher questioning is key in ensuring students experience the intended understanding. While these pivotal understandings are crucial in developing numerical fluency, it's not just about students having opportunities and experiences with these activities. For that to happen, it takes purposeful planning and execution of instruction. So purposeful planning is going to be very important moving forward. Some might even say it takes purposeful planning. And on that note, it would be beneficial for you to pause the video and spend some time reading Chapter 2 in your resource book. Welcome back. Did you have a lot of aha moments as you read Chapter 2? Renee and I sure did. And to organize our thinking and better understand the processes, we created this chart. This is one way we can think about instructional processes as they relate to number talks, games, and story problems. As you can see on this chart, there's a direct connection between the 6 instructional processes and a well-known instructional path for elementary teachers known as CRA. Physically constructing provides students with a concrete experience. Representing graphically and symbolically, as well as visualizing, allows students to represent their thinking. Verbalizing and justifying provides an abstract experience for students as well. We can also see that these activities almost always get to all 6 instructional practices. However, we must be very cognizant of these sometimes blocks to ensure that students experience all 6 instructional processes. These are critical for numerical fluency development. These processes should be at the forefront of numerical fluency and planning. To see how these processes look in an instructional plan, check out page 32 in your resource book. Well, we've spent the last 3 sessions diving into fluency, splashing around with ideas, and surfing into understanding. We hope you've enjoyed this wave of information as much as we have. We can't wait to see your reflections and ahas. And be sure to check out our summer version of Mathcation. More information on that will be coming soon. So as we sail away, we'd like you to visit your digital journal for the final time during this Mathcation experience. Spend some time reflecting on the prompts and sharing your favorite moments from Mathcation. And we will see you next time.